Hello and welcome back. This will be another pretty quick video actually on composition and interface-based design. So we're still kind of discussing the alternatives to inheritance, and then we're going to sort of tie this into dependency injection. So we talked a lot about composition versus inheritance in the last video and why one does just sort of make a little bit more sense than the other. And we're going to sort of deepen that discussion here. So some of the reasons why we might want to choose composition over inheritance is because of just how flexible it is. It is so much easier for us to swap behaviors without having to rewrite entire hierarchies. Fixing an entire hierarchy that may have just dozens or hundreds of subclasses could be so complicated. When pieces are like little individual pieces, it's much easier. You can think a little bit of it like, honestly, Lego blocks. When we build big Lego structures, if we keep all of our pieces sort of organized nicely and each piece gets built sort of as its own individual unit, that's why they separate it by bags. And then we have this like plug and play idea of sticking all of our components together. One mistake, we pull our component off, we fix it up and we plug it back in. But if we instead did it more as one giant building all the way up without this sort of more component-based structure, making a mistake could mean having to do a ton of rewrites, right? Have to take apart a ton more bricks than just some individual modules that we've connected together. This, of course, then also means it's more testable. We can mock individual parts for our unit tests, as we've seen in previous weeks. And of course, this means it's also reusable. Each of these individual pieces can come apart and be plugged back in somewhere else. We can have same behavior being shared by multiple classes that maybe are otherwise unrelated. Setting things up in these sort of modular component-based pieces is going to allow for that reusability to really be powerful. So when we do inheritance, we might be forcing a bit of a relationship that just doesn't feel true. This is sort of an extreme example, but we have this idea of like a credit card payment that exists where you can make a payment to from your credit card to a bank, for example, and then along comes PayPal and its ability to do the exact same thing. And rather than rewriting any code, we recognize, oh my God, PayPal just does the exact same thing as a credit card. And we set it up to just extend credit card payments for right now. And then later on, of course, this is not a true is-a relationship. It is not a type of credit card payment. And scope, abilities, responsibilities shift and change, and now we have a big rewrite ahead of us, right? So instead, perhaps we have this payment method option as an interface, and now we've decoupled those pieces. Now if an order goes through, regardless of the type of payment that's being made, we can just pass in the payment type. We don't have to specify, oh, it's a PayPal payment method or a credit card payment method. So when we want to put all of this together really nicely, we can see that many small plugs are going to be better than one giant plug, right? This helps us with our composition, just as it did with inheritance hierarchies. Now, our interface segregation principle also tells us that we are going to prefer small, focused interfaces, right? A client should only need to depend on the methods it actually uses. This also ties into single responsibility principle, right? A method should have only one reason to change. We only want to have that single responsibility. So we're only giving objects the abilities that they need to have, and we're assembling our behavior from small, focused parts, right? We're going to avoid tangling big interfaces and cross-inheriting parents and all that stuff. So here we have this example that we kind of looked at a little bit in the last video. We have studying and we have teaching. So somebody who implements the studying or studyable interface can study, teachable, they can teach. Now we have this idea of a class that has a student role, they can study hard. We have this teacher role, they can teach. And then we have this student-teacher class, which was me all the way through school. And rather than me trying to implement both studyable and teachable and then having copied code, or me having to figure out how to like extend multiple classes, which does not work in this language. Instead, a student teacher has a student role attached to them, and they have a teacher role attached to them. Whoops. So what does this actually mean? It means that now I can attach both of those types of roles to my student teacher role, and both of these methods can just call a student role or a teacher role method. Problem solved. Now, of course, this does mean that I'm not able to put people with a student role and a teacher role and a student teacher role all in an array list together, right? So this doesn't always work in all scenarios, but it does make sense actually for a lot of them. A lot of this course, as we've seen, is it depends, right? It just depends on the scenario. Now, here's the alternate solution. As I just said, that solution may not work if you needed to like put it all into an array list of payment methods, an array list of students, right? A student teacher wasn't really a type student or a type teacher. They're their own package of individual, right? So the alternative to that situation is to pick the behavior you need at runtime. And while we'll discuss many different patterns in the coming weeks, this is the first one we're really going to see. And this is the strategy pattern. So the basic idea is that we define a strategy interface for a family of behaviors. For example, a payment method. And what's the behavior? We can make a payment. That's it. Right? We store a reference to the strategy in the context of the class. So once again, it's not an is-a relationship in the main servicing class. It still has a, but now we can do this swapping out the behavior at runtime without having to worry about changing the context of this class itself. So we have an interface. We have multiple different strategies that sort of implement that interface so that they each handle their own stuff. And then we can have a payment processor that's separate, and this will actually handle the payment processing individually. This is the most common one that we see, but that doesn't mean that there aren't other ways to handle this composition. This composition, of course, does still have this implements. But keep in mind, so did this one as well. The difference being where the work is actually being called from the front end or where it's actually happening in is happening inside potentially student teacher over here, potentially over here inside payment processor, right? We don't interact directly with either of these from the front end. We run everything through a third party, a payment processor. Right, so we're picking the behavior we need at runtime. So here at runtime, this is happening, let's say in main, payment processor equals, well, if we need a PayPal payment for one website, we can just pass in the new PayPal payment and process it through PayPal, and PayPal will own all of the things it needs to own regarding that processing of the payment. If instead it's a credit card payment, a debit card payment, a cash payment, each one can handle its own processing. Now, other strategies do exist, and we will look at some of them in other videos, but we won't end up looking at all of them. So I've included just this QR code is for the same link right here, but we're going to basically be going through, not all, but this full list here of Refactor Guru. They have a bunch of different design patterns. I'll be pulling design patterns from this website. So if you want to take a quick look, you can. Again, we're not going to go through the entire catalog of design patterns, but I will be sort of focusing in on the ones that I most commonly see in this course as ones that would benefit students to implement. But consider this required reading, because surely it will also be required reading in Learn. There'll be a link to this, suggesting that you go through many different design patterns, because there may be some that you need. That just because we don't talk about, it doesn't mean that you can't use it. You still can, right? Once we're using this idea of a strategy method, this strategy pattern, testing becomes crazy easy, because now we can just swap in these mocks. We don't need to rewire anything. We can just make a mock payment class or a stub payment class or a fake payment class, whatever it might be. We saw this in our refactoring last week. And now in our test, we can just say new mock payment, and it beautifully will test it. We're not depending on the actual payment methods at all, because I don't care about those. What I care about in my test is testing the processor's process function. This will allow me to isolate that, which is going to be faster, more secure, and more reliable for what we're trying to test. So like I already said, right, everything in this course is it depends. Often this is referred to as the it depends course. It's very easy to overuse this idea and add interfaces and composition until you're blue in the face, right? Just everywhere. Again, I give you this tool, I give you a hammer, everything looks like a nail, right? So rather than doing that, let's take a moment to pause and reflect on our projects where we actually sit down with our group and discuss this idea. So take some time to sit with your group, look through your project, and find a few key themes where it feels like using interfaces and composition is going to help you long term. Make some tickets, and then you can make a plan to actually implement these refactors later on. So don't just go off on your own and turn every single class that you have into having an interface. Yagni. We're not going to do that. Instead, sit down collectively, make some really smart decisions, and then implement those into your project with a lot of meaning behind them. Defensible decisions, decisions that you can say, this is why we chose these classes needing an interface, right? It's not everything. It's very, very specific. Cool. So take some time to look through your project and do that. And I will see you all in the next video. Bye.